So, metallic bonding. It's not actual bonds the way we think of most bonds. What happens is that atoms with low electronegativity values that are going to be just within near proximity. And they are that way because the atoms pack closely to one another in a regular arrangement or pattern. And the electrons are going to be swimming around them. So we're dealing only with metals here. Atoms are packing closely. Okay, so here's a little image of it. They're just packed nicely one by another. We have what are called delocalized valence electrons. So we have electrons that are moving between all of the metal cations, which is good for us. That's how we get electricity and how I'm getting power to my computer right now. So we can think of all of the metals that are involved here as cations because those electrons are moving in between them. We don't have those valence electrons actually as part of the atoms anymore. And those electrons that are moving around kind of act as the glue that hold the cations together. So M+ means the middle cation. Okay. So here's another image. So we've got nice orderly cations with the electrons moving around between them. So why are metals malleable and ductile? It's because of the attraction between the cations and the electrons, not because the cation is reacting with another cation. The cations can move around in groups without breaking any of the so-called bonds. Because they're just held together by those moving electrons, we can move and bend and shape them. This is difficult, though, when we have metals that have atoms of different sizes mixed within. So alloys, things like steel. Yep.
So is this real bonding, or is it kind of like hydrogen bonding?
It's kind of like hydrogen bonding. It's not quite really bonding the way we normally think of bonding. Good. So here we have an example. We've got a bunch of one type of atom, and then mixed within we have some other atoms. So let's say we've got some copper and tin, perhaps. Got a bunch of, let's see, the tin would be bigger, so nice green tins. Copper is the little white ones. They're kind of getting in the way of that nice moving and bending that we were talking about. They can't move in those groups past one another as easily because we have these oddly shaped ones in it anymore. We do know that metals are good conductors. The electrons are going to move very easily. And we can carry an electric current throughout. They're also good conductors of heat. Okay, the strength of metals. It depends on the amount of electrons that are shared. The more electrons that are shared, the stronger the metal is. And a lot of the transition metals get kind of difficult for us to tell because of that D energy level. We can get delocalized electrons in differing amounts, which is rough for us. It also depends on how far the electrons are from the nucleus. We know that the further they are, we have the electron shielding, so we're going to have the electrons held more weakly. Well, if they're held less to the atom that they originally were with, it also means that it's going to hold other atoms of the same type less strongly together. Okay, some physical properties, 4-5. Some physical properties that you should, going back a little bit to the impurities. An impurity is anything that disrupts the regular order. And this could be with metallic, quote-unquote, bonds, or it could be with any other sort of thing that we have. Anytime we put something else into it, it's going to disrupt that regular order. It's going to weaken bonds, lower melting point, and affect solubility and conductivity. And sometimes that effect means that it's more soluble. Sometimes the effect, depending on what we put in, is less soluble, more conductive, or less conductive. Depends on what we're doing to it and what it was to start with. Alloys are metals put together. So metals are insoluble in other substances, but if you put a metal with a metal, they're going to be soluble within one another, so they're going to be able to mix. I can mix metals. I can't mix a metal with water. I can have a chemical reaction between a metal and water and rust something, but I'm not going to just be able to mix them together. Metals and metals I can mix together to form an alloy. Some of the most common alloys are brass, which are copper and zinc, amalgams, which are really any metal cation with mercury, and steel, which is iron and carbon. Yeah.
What were bells made out of again?
Yeah. Iron and carbon, yeah, which normally is not, it's not a metal, but carbon is very special. Yeah. That's a good question. Not sure off the top of my head. Ionic solids, we have repeating ions. We talked about that with that crystalline shape. And that's all that I'm going to tell you, which is good.